Today we will be multiplying a monomial by a polynomial. So let's just take a look real quick. We talked about a monomial in the last part. Remember, a monomial was just one term because mono means one. Well, a polynomial, poly means many. So we're going to end up multiplying a one-term value, like 9 here, or 2x, or 3x to the fourth, by a multi-term polynomial. Well, in this case, just a binomial because there's two terms, or a trinomial because there's three. And that's pretty much all we'll end up doing in this case. So what we'll end up using is another property. Remember, last time we used the commutative property exclusively. Well, here we're going to end up using the commutative property, but before we do that, we're going to use the distributive property. So we're going to take this 9 here and multiply it over this addition. So here's what it will look like. We'll take that 9 and we're going to multiply it by 2x squared. So we did 9 times 2x squared. Then we're going to take that same 9 and we're going to multiply it by the 3x. So when we do this, we end up now using that commutative property and bring the coefficients next to each other. Well, they're already next to each other, so we can go ahead and multiply. We end up with an 18x squared. So I just did 9 times 2, and then brought down the x squared. Here, 9 times 3 makes 27x. And there's our answer. We cannot add these two terms because they're not like terms. Like terms have the same exponents on the variables. Here they both have x as the variable, but this one has an exponent of 2 and this one has 1. Well, the next problem is a little bit tougher because we have a monomial in which we have a number, a coefficient, and a variable. So just a little extra work here. We still use that distributive property. So remember, the distributive property has actually a longer name. It's called the distributive property of multiplication over addition. So even though we have a subtraction sign here, you can think of this as plus a negative. So we're distributing the 2x over that addition. Just happens one term is negative. So again, it looks like this. We're taking this 2x and we're multiplying it by each of the terms inside. So 2x times by the 3x to the fourth. And then again, we have that same 2x, so plus 2x times by, and then we have that negative 2x squared. So you see how we're taking that 2x and we're multiplying it over both numbers in the parentheses, or how many ever numbers we have in the parentheses. In this case, just 2. So we go ahead and do this work here. We multiply the 2 and the 3. It gives us 6. X and x to the fourth. You count up how many x's you have. You got 5 altogether. So 1 and 4 make 5. So over here, we have a 2 times by negative 2. Well, that gives us a negative 4. And then you count up the exponents. So you got 1x here and 2 x's here. Make 3 x's altogether. And there is our answer. Well, here's another example of using that distributive property. We've got to now multiply it over what we call a trinomial. So a polynomial just means many. It could mean any number. And we basically just have more than one. But if they are just two terms, we have more specific names for them. We call them a binomial. 3 terms a trinomial. After that, they just call them polynomials. So we're doing the same thing. We're taking this 3x to the fourth, and we're going to multiply it over each of the terms inside the parentheses. So you see how we have that 3x to the fourth times 5x to the fifth. And we take that same 3x to the fourth, and we're going to multiply it over this time the 7, or actually the negative 7x squared. And we go back and we multiply that same 3x to the fourth, but this time over that 3x. So notice here, that again, it's the 3x to the fourth being multiplied over each of the terms. And so from there, it becomes a problem like we just had solved, the monomial times a monomial. You're just multiplying the 3x to the fourth by 5x to the fifth. Those are two monomials. We're multiplying them together. So you take the coefficients first, which make 15, and then x to the fourth and x to the fifth make 9 x's altogether. Do the same thing here. But this time, watch the signs here. 3 times negative 7, negative 21. Count up the exponents. 4 and 2 make 6. And then do the same thing over here. 3 and 3 multiply to make a 9. Then you count up the exponents on the x's. Here we have 4, here we have 1, so it makes 5 all together. And so there's our answer. We can't combine any of the terms. Even though they have the same base, they have an x, they don't have the same number of x's being multiplied. So not the same exponents. So same sort of thing on these problems. You're multiplying this monomial by each of the terms inside the parentheses. So it would look like this. 5xy to the second times by, and then you just take it, the term inside the parentheses, and write that down. And then you do the same thing. So it's a plus, and then you have that term on the outside, the 5xy squared, multiplied by this time, it's a negative 5x to the third y. And so then it becomes a problem just like we had done in part 1, where we're multiplying monomials together. 5 and 2 make 10. Then you count up the x's. You've got 1x here, 4 x's here, make 5 x's all together. Then you count up the y's. You got 2 y's, and 2 y's make 4 y's. And then you do the same thing with the next group. You got 2 monomials here. 5 and negative 5 make negative 25. And then you count up the exponents. You got 1x and 3 x's make 4 x's. Count up the y's. You got 2 y's and 1 y make 3 y's. And there's our answer. So again, you can't combine them because they have different exponents on the variables. Well, a couple more examples here. Take a look at this one. And here we are taking a negative 2a squared c and multiplying it over 2. So the difference here is we just have different variables, different exponents on the variables. Let's see what ends up happening. So we're taking that 2, or that negative 2a squared c, and we're going to multiply it by each of the terms in the polynomial. So we've got 3a to the third c right here that we're multiplying. And then you do the same thing again. You've got a plus, and then we're doing negative 2a squared c times by, and then whatever term is inside the polynomial. So this time a 2a squared c. And so when you do this, you're taking the coefficients and multiplying them. Negative 2 and 3, you get negative 6. You count up the a's. You got 2 a's here, 3 a's here, make 5 a's all together. You count up the c's. You got 1 c here, and 1 c here makes 2 c's. Well, in the next part, negative 2 and 2 make a negative 4. And then we count up the a's. You got 2 a's, and 2 a's make 4 a's. Then we count up the c's. You got 1 c and 1 c again. Well, that just makes 2 c's. So there it is. Now again, these are very close. Here we have a to the 5th, c to the 2nd. Here we have a to the 4th, c to the 2nd. Even though the c's are the same, the a's are not, so we cannot combine them. Well, this last problem is going to be similar to the last problem you see on tonight's homework, number 12. And what's difficult about it is that it's different than the other problems. See, this one seems a lot longer, this monomial here. Well, it's because it's actually 2 monomials. We've got one monomial right here and one right here. So we can collect this and make this a simpler problem. So that's what you need to do first. So negative 3 times by 1 makes just negative 3, but we can count up, we got more a's that are in common. Let's go ahead and bring those together. So it's a to the 6th power, because we have 2 a's and 4 a's make 6 a's. Count up the c's, you got 1 c and 1 c make 2 c's. So now that looks a whole lot simpler than what we had before. So then we just rewrite what we have, except it's not a 2, it's a 5. And so we have 5a squared c minus 2ac. And so now it becomes a problem just like we had solved before. So we're going to take this monomial and multiply it over that subtraction. So here, let's see if we can do this all in one step. Negative 3 times 5 makes negative 15. And then let's count up the a's. You got 6 a's here, and you got 2 a's here. So that makes a total of 8 A's. Let's count up the C's. You got 2 C's here and 1 C here. So that makes a total of 3 C's. Now we'll do the same thing here. We're going to multiply negative 3 by this negative 2. And so that makes a positive 6. Then we count up the A's. You got 6 A's and you have 1 A. So it's 6 plus 1 makes 7. 6 and 1 makes 7. Well, we got the C to the second and the C to the first. So that makes 3 C's altogether. 2 C's and 1 C make 3 C's. And there's our answer. We cannot collect those even though the C's are the same, the A's are not. So that's as far as we can take the problem. So those are some of the problems you'll see on tonight's homework.